the crap out of people, okay? All right, so Danae, go ahead and can you tell us what did you get for problem number 1? 21, very good. So this is a, what kind of relationship do we see here? Complementary. So Trevante and Fluffy, make sure you're paying real close attention since you guys were absent. This is a complementary angle set because it forms that L. So we want to make sure that we set it up so that it's equal to 90. So that means we're going to take the angle 2x plus 12 and we're going to add it with the angle 36 and we're going to set that equal to 90. Well, now we need to go ahead and simplify. So obviously on the right side there's nothing to simplify, it's just the 90. But if we're looking at the left side, there are things that we could actually do, things that we can actually simplify in order to start the process. Like that positive 12 and that positive 36. They're both numbers that can be combined together. We do know what that value would be together. So that's what we're going to focus on. We're going to focus on a positive 12 plus the 36, which is going to give us what? 48. Good. So now we've got, instead of the plus 12 and plus 36, we just have plus 48. So we have 2x plus 48 is equal to 90. That left side of the equation, that's simplified now. There's no more that you can simplify it or condense it down. So now we start going ahead and doing inverse operations to solve. So the first inverse operation you're going to focus on is getting that constant moved to the other side. Okay, so we're going to subtract 48 from both sides of the equation. That's going to leave us with 2x equals 42. And then we'll divide both sides by 2, and we'll get that x is going to be equal to 21. And we're done. So the value of x is going to be equal to 21. All right, so Hufflepuff is going to get points. Shh. All right, because you're Hufflepuff. Yeah, because why did somebody say wait? How much? 20. Number 2, Manuel. To what? It's not 84. McClure? Not 42. Courtney? 28. Very good. X is equal to 28. What kind of angle relationship are we seeing here, guys? Supplementary. Very good. So we know that this is a supplementary set. So since it's supplementary, we're setting up the equation as an addition problem where we're taking 2x and we're adding it with the 96 and adding that with the other x. So all three angles are being added together to equal 180 degrees. It's going to be set equal to 180 degrees. So like we did before, we cannot simplify the 180, but we can cover that up and we can condense this expression down. What stuff can we combine together? The x's, right? We can combine the 2x and the x together. 2x plus x is going to give us what? 3x. So 2x plus x is going to give us 3x. We still have that plus 96, and it's equal to 180. Everything's condensed. It's simplified down. Now we start solving. So we're going to subtract 96 from both sides. That gives you 3x is now equal to 84. And then we divide both sides by 3. So that's what you forgot to do, Manuel. You forgot to divide by the 3. So you're going to get that x is going to be equal to 28. Okay? Any questions about that? All right, it's the same kind of idea that we're going to be doing today, but now instead of it just being angle relationships, we're focusing on just triangles. So that's our focus for today is triangles and the angles that are inside of triangles. So the first thing that we have to have an understanding of is how many degrees a triangle is going to be equal to. So does anybody know what the total sum of the degrees in a triangle is? What do you think, Santiago? 180. Very good. Ravenclaw gets some points. Okay, he'll get 10 because that was an easy question. All right, so triangles, all triangles, no matter what type of triangle it is, if it's a right triangle, an acute triangle, an obtuse triangle, it's always going to have a sum of 180 degrees. So let's go ahead and write that sum theorem down. So we call it the Angle Sum Theorem for triangles. The Angle Sum Theorem for triangles. And what it entails is that if you have a triangle with x degrees, y degrees, and z degrees, so these 3-degree measurements, if you add those together, so if you take x plus y plus z, it's going to be equal to 180, no matter what. It will always equal 180 degrees. Always, always, always. So the sum of all 3 angles of any triangle is always equal to 180 degrees. The sum of all 3 angles of any triangle is equal to 180 degrees. What's up? I always do. That's how I draw my Z's. That's just how I write my Z's. Everybody does things differently. So like when I'm doing an algebraic x, it's different than my x when I'm spelling something. Okay? All right, so if I have the following triangle, and I'm stating that this is 119 degrees, and that this one is 43 degrees, and that this is x, and I want to know, okay, well, what's x going to equal? Then you just have to set up an equation. Like we said before, it's the sum of all 3 angles. So sum means I have to add them all together. So I would have to create the equation x plus 119 plus 43, and it's always going to be set equal to 180, no matter what. It's always equal to 180. And you always have 3 angles because it's a triangle. Think of the word tri. You know, if you have tricycle, it means you've got 3 wheels. A triangle, you've got 3 angles. 3 sides, 3 angles. Okay, so now it's just the same thing as what we were doing previously. You've got to simplify before you solve. So what can we simplify down? Caius? Very good. We can simplify that 119 and 43 because they are similar. They're both just numerical values. They're both constants. So you can actually combine those values together. What is a positive 119 plus 43 going to yield? 162. Good. So we have x plus 162 is equal to 180. And now you just solve it. What are we going to do to solve? Good. So subtract 162 from both sides. And we'll get that x is going to be equal to 18 degrees. X is equal to 18 degrees. Well, there's some situations, like if you notice up here when we were doing our warm-up, I didn't put the degree symbol, did I? Although for for this one, I should have, because of the fact that x is actually a value, so I should have put the degree symbol for this one. But for here, I didn't, because x in this case is not the degree. X is part of the expression for the degree. The degree is 2x plus 12. X is just a value. This is 36 degrees, this is 2x plus 12 degrees. But x is just the number that you're solving for that you would substitute in to find out how big it is. In this situation, x is just x, and it represents the degree of that angle. So I do need to put the degree symbol there. If x is by itself, if it's just the variable alone is representing the size of the angle, then you should put your answer with the degree symbol in it. But if the size of the angle is actually an expression of the variable, like, oh, it's the variable plus something, or it's the variable times something, then you don't have to put the degree symbol. If you don't put the degree symbol, I won't count it wrong. If that's what you're worried about, I'm not going to count it wrong. Okay? But I did have several people asking today, why is it that you put a degree symbol sometimes and not others? Yes? That's not an equilateral triangle. This is not an equilateral triangle. This is a scalene triangle because it has all three different measures of the angles. So what he was trying to do, the vocabulary, scalene means that every single one of the sides has a different measurement, which also means every one of the angles has a different measurement. If it's an isosceles triangle, then you have at least two sides, which means you also have at least two angles that are equal to each other. If it's an equilateral, that means everything is equal. All your angle measurements are equal to each other, which means also that all your side measurements are equal to each other. Okay? And we'll see examples of some equilaterals and isosceles triangles too. Okay? Who can raise their hand and tell me what type of triangle is this? Tyler? A right triangle. Okay? It's a right triangle because it has a right angle inside of it. So that means that the triangle is also called a right triangle. Now, because it has a right angle inside of it, what do we know that right angle measures? 90. Okay? So I don't have to state that that's a 90-degree angle. I could just put that little box there, and it should be known that it's 90 degrees. So I have this right triangle with x degrees missing, but I do know that this one's 35. So who can raise their hand and tell me what is the equation going to look like? Diego?
35,
Well, was every triangle always equal? 180. And that means that there's a sum of all three angles. You've got two angles written. What's the third angle again? 90. So don't forget to include that 90. And that all equals 180 degrees. So sometimes the question might not necessarily be, oh, solve for the x. Maybe it might be, what is the equation? So you have to know how to set up the equation correctly. Now, again, simplify what we can. What things can we combine together? 35 and 90. Very good, Kelvin. So we can combine 35 and 90 together. So now we're going to have x plus 125 is equal to 180. So what's x going to equal? 55. 55. So we're going to subtract the 125 from each side, and that'll give us x is equal to 55 degrees. Who knows what that means? Chase? It's an isosceles triangle. So since that is an isosceles triangle and we know that this measurement is 68, then we know that these two measurements are what? Well, they're not 68, but they are equal to each other. They're the same. So both of these measurements are actually going to be equal to each other too. So I can actually label them both x. They both can be labeled x because they are the same measurement. So when I set this equation up, I have x plus another x plus the 68, and that's equal to 180. What can I combine together? Nicole? The x and the x. What is that going to equal? 2x. Good. I can combine the x plus x, and that's going to equal 2x. So I now have 2x plus 68 is equal to 180. What do I do first to solve it? Tyler? What am I going to do first? For this one. Thanks, Diego. You're going to subtract the 68 from both sides first. That's going to give you 2x is now equal to 112. And then what's next? Divide it by 2. Good. So we'll divide both sides by 2, and we're going to get x is equal to 56. And it's 56 degrees. 56 degrees. Okay? We're going to go ahead and stop here. I don't want to give you homework tonight, so you can have a nice little free weekend. I think you guys did enough studying.